Okay, so in last session we discussed about the building of battery pack. Okay, I hope that session is clear to everyone. In today's session, that is the second video, we will be discussing about the next parameters. So what we are doing, we will make one circuit called as a battery cutoff circuit. What is battery cutoff circuit? That means that okay, you are charging your battery pack. Okay, once the battery reaches 90% or maybe 80%, 70%, depends upon the requirement, you have to plug off the charger. Okay, so that is the requirement of the model. Agenda of the model is to create the cutoff circuit, charging cutoff circuit. That means we are charging the electric vehicle battery pack, okay, or maybe any applications battery pack from 0 to 80% or 0 to 90%. And once the battery pack reaches 90%, we have to cut off the supply of the current, or you can say voltage, to the charger, from charger to battery pack, not to charger. You can name also on the screen. Suppose I want to name somewhere, so just left click, same process, left click. Okay, and you want to name, suppose that name battery cutoff charging. Okay, so actually the process is same, so you will be observing it is being typed in the search region. So I don't want in a search region because I don't want to search the battery cutoff charging. I want to create the annotation. So simply pick on it, battery cutoff charging. Yeah, you can customize the color and all. Just go there, select, press Ctrl A for selection, change the size. Suppose you want to make it 18 and keep some bold or red, whatever you want, you can keep. This is the topic name, battery cutoff charging. Okay. So our agenda is to charge the battery pack from 0 to 80%, okay, or maybe 20 to 80, or maybe 50 to 80, whatever, that depends upon our requirement. We can build the simulation model for the same. So let's take a, we discussed in last video that how to take a battery pack. Okay, so we are taking a very small battery pack. Actually, I am connecting two cells in series only. There is no parallel connection. You can try for the big battery pack also, but I told you, now initially when you are learning something, try with a smaller model. Later you can try with the big model. So I'll be taking one battery, okay, and let's name as a cell one. Let's name as a cell. And if you create a copy, how to create a copy, I discussed in last video. Just right click and drag and drop. Since the first cell is named as a cell one, the second will automatically come as a cell two. Okay, and if you further create the copy, it will be cell 3, cell 4, cell 5, like that. Cell 1, cell 2. Parameters you can fill. See, suppose that I am going with the default parameter 7.2, 5.4. Yeah, initial state of charge. Okay, means that what is the charging percentage in the cell. Okay, so let's say I am going with, let's say, 60%. That means my cell is 60% charge. Yeah, remember one thing. This is the one cell charging percentage. Actually, it will be for the whole battery pack, the charging percentage. Okay, so as of now, you give 60% as the initial state of charge. The battery response time is how quickly the battery will respond to your input. That means whatever you are doing with this battery pack, either you are connecting charger or load, or you are making some other things, how quickly the battery will respond to your model. How quickly the battery will respond to your build model. Cell or battery pack, whatever. If you take one cell, it will be for one cell. If you take a complete battery pack, it will be for a complete battery pack. So as of now, don't do anything. Leave it for default. Only one parameter I changed. That is initial state of charge, 60%. Okay. So that I have to do for the below cell also. Double click here. Okay. And just go to same initial state of charge, 60%. So two cells we have to connect in series. When you connect the cells in series, what is the procedure to connect? Yeah, you can connect negative to positive. See, and one positive and negative will remain behind. Okay, yes, correct now. So battery cut off charging. Okay, when you want to cut off the charging, okay, when I want to cut off, I want to cut off at 80%. Let's say, for example, you can type here 80%. You want to cut off at 80%. If you want to cut off at 80%, that means what we have to do, we have to measure the SOC of the battery pack. Okay, we have to measure the SOC of the battery pack, right? We have to measure the SOC of the battery pack. Correct. So how to measure the SOC of the battery pack? Now it is actually it's a battery pack of two series cell, right? So how to measure the battery pack SOC? Okay, we have to use. You can't directly measure. See, I am going very slow. You can follow. Okay, if somebody is new to MATLAB Shimuli, he can also understand. Okay, just follow this videos. You will learn the electric vehicle simulation and design. It's not so much difficult. Only you have to follow certain steps. It's a steps based software. So you have to, I told you in last video that measurement port will give me the measurement of certain things. What are that certain things we don't know? Why? Because it will not show directly. Whatever for second also it will not show directly. So what we have to do? A block is there, a bus selector. What is the block name? Bus selector. Going very basic. Okay, for electrical student, electronic student, mechanical students also. Okay, except civil and CSIT, you can learn this course. Mechanical huge opportunities in this model-based design. MBD approach. Actually, we are building a model. Okay, so I'll be discussing in one session about what is model-based design, what are the industrial applications. But as of now, okay, let's say I took one bus selector. If you want to show the block name, yeah, we can do so. Just go and check once, which is show block name. Okay, so I have to connect this measurement port to the inputs. Always left hand side is the input. See, I'm connecting it here. Okay, I told you if it lines are going in a circumferential way, press the that block, press Control I. See, done. Now we can see it is coming something signal 1, signal 2. That means this bus selector is giving me the measurement of two things. Signal 1, signal 2. I don't want signal 1, signal 2. Why? Because I don't know what is that signal. Yeah, I don't know. So that is a residual signal. So if you want to get specific measurement, you have to click on bus selector. See why it came signal 1, signal 2. You can see here a dialog box will get open. See in selected element signal 1, signal 2. That's the reason why signal 1, signal 2 came. So I have to remove this signal. No, press signal 1, remove signal 2. Why? Because I don't want signal 1, signal 2. What I want, SOC current voltage. So actually left hand side is the elements in the bus. What are the available elements you can measure? Right hand side is selected elements. So what I want SOC to measure. I don't want current and voltage as of now, but if you want you can take that also. That is the current and voltage. Just pick on SOC, click on select. See, SOC came in the sync. Similarly, if you want current, you can select. If you want voltage, you can select. You can press control also to go for the selection and deselection. I don't want current and voltage. Press control, press current and voltage, remove it. See. So out of the available signal, SOC, current and voltage, I selected SOC only. Press apply, press OK. So what will happen? Only one signal will come, that is this. Delete the other one. See, SOC is coming. And why I am measuring SOC? Why? Well, we have to give the instruction of battery cutoff charging 80%. 80% is the state of charge, right? So we have to give the instruction 80%. 80% is state of charge. That means how much is the charging of the cells or battery pack. So we have to give the instruction for the SOC, right? That's why I measured the SOC. What is the instruction I have to give? That 90% should be the cutoff. Sorry, 80% should be the cutoff charging. That means when the SOC is reaching 80%, there should be no supply of the electric current to the battery pack to charge the battery pack. Is it correct? So first of all, to charge the battery pack, what is required? We require one voltage source. There also you can click on the left screen, take DC voltage source. See, pick in on it, show the block name. Why? Because initially for few session, show the block name. So positive will go to positive, negative will go to negative. This is charging my battery pack in default. Default means we don't have any instruction. If you see the output right now, what will happen? You are charging the battery pack, okay, with some DC voltage source, but you don't have any restriction. It will charge completely up to 100%, right? It will charge completely up to 100%. Yeah. Let's say the cell is 7.2 volts. So since we connected the cells in series, and you know the basic of electrical, when you connect the cells in series, the voltage will increase, right? When you connect the cells in series, voltage will increase. So 7.2 for one cell, 7.2 for other cell, 7.2 plus 7.2, 14.4. You can charge comfortably by 25 volt. It should be greater than the voltage of the battery pack. Simple. So we double click on it, make the voltage 25 volt. Simple. So as of now, I have two cells connected in series that is being charged by 25 volt DC. And what is the SOC of one cell? 7.2. Sorry, voltage of one cell 7.2. 7.2 plus 7.2, 14.4. I am repeating and charging with a 25 volt. Okay, so perfectly charging battery pack. But I don't want to charge completely up to 100%. I mentioned. Okay, we have to give the a circuit that will stop the charging for the 80%. So how to do that? Actually, you have to give one switch, because if you want to stop something, okay, you have to give a switch. Simple. If you want to stop something, we have to give a switch, as it's very basic, right? So actually in simulation, okay, we have a lot of switches. Okay, let me show the switches. If you take a MOSFET, it is a switch. Okay, metal oxide semiconductor field effect transistor. See, you can take IGBT. It will also act as a switch. All are switches in the simulation. See, take a circuit breaker. Okay, it is also a switch. Okay, so we will be using this is not circuit breaker, actually this is circuit breaker. We'll be using this I mean to say switches as per our requirement. Okay, uh, we can use not circuit, it's called ideal switch. Actually, I'm sorry, it's the ideal switch. See, this three will be using, okay, for the switch on and off operation. You can see here MOSFET, isolated diode, ideal switch. Remember? Okay, so if you see here, all switches contain the same thing almost. G for giving signal, gate pulse, that means when to turn on, when to turn off, and D and S to connect. Actually, technically D is drain, S is source. Just for understanding, we have to connect actually on one side, one for positive, one for negative. Similarly, G is the gate signal, control, and emitter, right? collector and emitter. For IGBT diode, it's a collector and emitter. Ideal switch 1 and 2 to connect on either side. Okay, actually, okay, don't go into so much technical. Okay, for simulation, uh, okay, it is enough to know that we have a drain and source, positive and negative, because these are in the academics. If somebody is in electrical electronics background, he can understand a better way what is D and S, what is C and E, what is 1 and 2. Okay, as of now we will be using only 2 for the connection purposes. You can use any switches, okay, but I am using here MOSFET. That means my MOSFET is a switch. So come here, okay, and just delete this line, delete the main line. Why? Because I have to connect as per the switch. So simply press and control I. Why? Because source will go to the positive, drain will go to the negative. So one side will go to S to positive, D to positive. Here the current is flowing like source to drain. Okay, see, I took repeating. I took a DC voltage source. I took two cells connected in series. I took the bus selector to measure SOC. I took the MOSFET to give the instruction when to turn on and off the switches. And measurement I don't want now, so just double click on it, uncheck the measurement. This you can do in a switches. We have the option to uncheck the measurement port. In battery we don't have. Remember in last session we did the terminator block to terminate the measurement port of the battery. Here you can uncheck the measurement port, that will vanish. Click apply, click OK. See, now this gate pulse we have to prepare the signal. What is the signal I want to prepare? The instruction. See, and what is the instruction? If my SOC is more than 80%, I should stop the supply of current from the DC voltage. Am I clear? I am repeating. If my SOC is more than 80%, I should stop the supply of current from DC voltage source to battery pack. So for setting up the instruction, actually lot of things are there in the simulation. We'll be discussing with the session day by day. So I'll be making you expert within few days or maybe a month or 2 months. So for setting the instruction, we have the relational operators. Such relational operator. See, don't panic by observing the block. It's just for initial few days you have to remember the blocks. And for electric vehicle, we don't have so much block to remember. That's the beauty. We don't have so much block to remember. Okay, we have some blocks only. Okay, that will be using for EV design and simulation. Because MATLAB is used for a lot of purposes. We are not here to learn MATLAB. We are here to learn, okay, the designing of electric vehicle with MATLAB simulation. Okay, so connect this instruction we have to give, right? So what is the instruction I want? I want, let's say SOC will go to my first relational operator input, and what point I want to stop? I want to stop at 90, 80, sorry, 80. So give that constant 80. See, this is my 80. What will happen? Okay, see, let me explain the logic to you. Logic is important in simulation. See, logic is important. If you are able to understand logic, the blocks is just the way of learning to how to use software. Blocks is nothing, just a way to use the software. So this is the logic. What is the logic here? Suppose that SOC, what is the initial state of charge? 60%. So actually the battery will start charging. Why? Because we have the DC voltage source connected. So from 60 it will become 65, 70. So let's say it is 65 here. 65 is less than 8 is a true condition. That means the switch will be turning on, so the battery will be charged. 65 less than 80, yes, correct now. So the battery will be charged. Let's say it is charging and the SOC is reaching, let's say 90. My first input is 90. So it will ask the question, ask yourself, is 90 less than 80? No, 90 is more than 80. So you'll be getting 0 and 1. So 0 in this case, right? 0 means it will go to this gate pulse. That means switch will be turned off. That means the supply will be disconnected from DC voltage source to the battery pack. I will repeat. Let's say the SOC is less than 80. For example, it's 70%. Is 70 less than 80? Yes. So the output will be here 1. It will be 1 or 0. As of now, it's 1. Why? Because 70 is less than 80. If it is 1, the same will go to switch, okay, as a gate pulse. So what will happen? The switch will be on. If the switch is on, so definitely the DC voltage source will charge the battery pack. Right. And let's say the battery is charging, and it reaches 81. It will not go up to 90. Just I'm giving the example. One, as in when it is 81, 81 is not less than 80, right? So it will generate 1 as a, sorry, 0 as a output. So 0 will go to the switch and it will cut off the supply of the voltage to the cell. So the battery will be not charged. Simple. This was a simple logic. Correct. So when you are learning something, initially learn from the scratch. Okay, and spend some time on a software and logic part, because I'll be discussing some big model also with you. Okay, so that is beneficial for everybody who wants to make the career in the MPT sector. That is a model based design. Okay, so yeah, we have to see some output. Actually, to see the output, okay, you require one scope block, scoop or scope, whatever you tell. Okay, because it's a graphical output, you can't see in the display. Actually, display and scope both are used to see the output. This is display, this is scope. Okay, so since my output is a graphical output, why graphical output? Because SOC will start charging from 65, what I kept 60, yes, it will reach up to 80 and it will not charge further. So that is something that is dynamic. Okay, when dynamic something is there, we use the scope. Okay, right. So display is not required. I'll be showing how display will be used. So scope simply connect to the SOC. You can name the scope also. Let's name as a SOC. SOC, right? See, run. But before running the simulation, because in last session we only built the battery pack. Okay, we haven't run anything. So to run any electrical based simulation, what we can do, you can go for the power guide. Take a power guide. Okay, and it's actually a solver. It's a solver which will solve the simulation. Nothing special, just keep on the one side. That's all. So it's a model. So repeating, cells connected to the DC voltage source via MOSFET. Operator is there 80%. Once the battery will reach 80%, will turn off the supply of the power from the DC voltage source. Run it and let's see the output what I am getting. So you have don't do anything, it's compiling. Okay. Once the compilation part is done, you can see it will pop up ready. Go to SOC and see. Okay. So double click on the SOC scope to see the output. See what is happening. Here the battery is charging from 60%. It is reaching to 63.5. Okay. Our instruction is set on actually 80%, right? Since I ran for the 10-second only, so that 10-second is not sufficient to get the output. So it increase the time. Let's say I'm going for 100 seconds. So in 100 seconds, it will be possible for the cell to reach the 80%. Then only you can see the graph. So click on run. Okay. Now click on SOC and see. Still, yeah, it is reached. Can you see the graph? It is starting with 60%, reaching at 80%, and then again turning flat. Why? Because at 80% we have the instruction. See, you can see on a screen 60 to 80. Such a way you can set up the any instruction you want to 90. Just go there and go on 90. See, this is just a basic that I am discussing with you. Okay, once your all hands are set in the software, we'll be loading with the difficult models. Go to SOC and see 60 to 90. Why I'm not able to see? Because maximum is a 85 here, so I have to increase the time, right? Correct now. So it is 100 second. Do it, let's say 150 second. Click on SOC. It reaches to 62 here, 90 percentage, and then further stop charging. So this is the battery cutoff charging 80%. Similarly, we can build the battery cutoff discharging. Just let me know what to change here. Because I am charging, I can also discharge. So next video we'll be seeing how to build the battery cutoff discharging circuit. Okay.